Hi, this is Harish here. Welcome to DB2 LUW Tips and Tricks video tutorial part 127. In this tutorial, or the tip that I want to provide you is when you do concurrent index creation on the same table, it results in a deadlock situation. The scripts that I'm using are available for free download. The data files are available at db2lewacademy.blogspot.in. You can reach me at db2academy@gmail.com. Please subscribe to my channel youtube.com/db2lewacademy. This slide talks about the problem scenario and the question. The problem scenario is very simple. You just create an index idx1 on table 1 in CLP session 1 and like open another CLP session, let's say CLP2, and issue a create index on the same table 1. The index name is idx2. You can just play around with the columns and you'll see that it results in a deadlock. And please have some reasonably like 1 GB of table, table data, table with 1 GB of data in it, so that you can quickly switch over between CLP1 and CLP2. Now, the question is why it results in a deadlock. So why not allow creation of indexes one after the other? Like say, for example, if CLP1 is going the first one, it's creating the index, let the other CLP2 application wait, and once the index 1 is completed, you can start the creation of index 2. So you can go into a lock wait situation, but rather than that, it's going into a deadlock situation. So which is why I don't know. See, I mean, I'm able to see that if you create an event monitor and figure out, I'm able to see that okay, it's getting into deadlock, and it has to do with some kind of system catalog locks that are held on the syscat space, and the syscat dot tables, the systables, the internal tables that it is trying to update, right? So that is what is creating this deadlock scenario. But then why can't we handle it in lock timeout way, like allow that? So that's what the issue. And do not bring in parallelism here. I'm not talking about parallelism. See, parallelism, concurrency is different from parallelism. Parallelism is like you create index idx1, and that single activity itself will be split into multiple tasks, and you can execute them parallelly. So a single unit of work is executing in a parallel fashion so that it completes in a faster way, in a faster time. But concurrency is something like I am creating two different objects at the same time. So that's what I'm meaning. So because I don't want to hear suggestions like try with intra-parallel or parallelism kind of a setting. I'm not talking about parallelism here. So okay, as usual, so let's get into an example and see how this stuff works. Okay, so here I am in a Linux system, Arch OS. This is, I don't know, this is like a swag Arch OS, even though it's like a not supported thing. Like I think DB2 supports only Red Hat and Ubuntu Linux, and in general any derivatives of that. So, but any case, it's all the same. So I'm going to connect to test database. Okay, I have the test database here, and okay, we need the okay, so I'm going to connect to the test. It has the setting lock timeout -1, and it has I have already done these things. So create the table space, index space, create the table staff, and with index in a different table space, and load like 1 GB of data I am loading into this staff table. So you need to have some reasonably sorry about that. You need to have some reasonably good amount of data. And after that, what I'm doing is creating an event monitor for the deadlock situation, and I'm putting it into a file, and I'm activating the monitor. So let's go quickly do that. I think I have done till this load thing. So I'm just going to set the state of the event monitor to 0. Okay, I'm connected here. I'm going to set the state to event monitor to 0. Okay, I don't think that event monitor is there. So I'm going to create that event monitor, set the state to 1, and connect. You don't need to do connect reset probably. Okay, just copy that. Okay, paste it. Okay, done. And I'll copy the create index idx1 on this table. I'll not hit enter. Okay, and I need to create the same like another index idx2 on the same table, probably with a different set of columns. So I have copied that and I'm going to put that here. So I have to say db2 connect to test. Okay, done. And I'm not going to hit enter though. Okay, so before doing that, I just want to make sure that, okay, yeah, we are all set. So what I'm going to do now is hit, so idx1 I'm hitting enter, idx2 I'm hitting enter, and since it is having 1 GB of data, it's going to take some amount of time, because see, by the time we switch between app 1 to app 2, if the index 1 itself is getting created, like if you do with 10 records, you're not going to reproduce this issue. So have at least 500 MB, and it also depends on your size of the machine. Like my thing is like a virtual machine with like 2.5 GB of RAM and 2 CPUs. So it's really, yeah, you can see that, yeah, 2.5 GB of RAM with 2 CPUs. It's not very powerful processor also, so so that's fine. I mean, we need it that way. So okay, so both the indexes are now creating, but then one, like there will be a deadlock situation that should occur. We'll have to wait it out. So that's no other way. So the question is why we need to, so why I'm doing this event monitoring thing is, so once we capture what is the event monitor, we can see what are all the things and the details and all that, which application is what queries it is running, and you can see that there is an internal cache catalog cache lock, and there is a the catalog table sysibm.systables or something. So that those two locks or those two tables are conflicting, like holding conflicting locks with each other, and one is getting rolled back. So that situation, so I just wanted to show you that. So that's why I'm creating this monitor. And so once that is done, so we'll run this evmon utility to put this data into there and just get the thing that we needed. Okay, so let's just do that. Okay, it's going to take a little bit of time. I told you it's not a very powerful machine, and we have to do that. Okay, okay, it's taking a little bit of time. The thing is, why can't we handle that? Why can't we handle that with lock timeout? That is the question. So it's like, okay, so app 1 is getting the first choice, so let the index 1 get created, and then let the index 2 get created. So it can happen that way, but it is not happening that way. It will just roll back one transaction with the deadlock, like the 911 SQL code with reason code 2. That is what we should be getting anytime now. I'm sorry about that. It's, yeah, so you got it. So 911 and reason code 2, that is like a deadlock scenario. It's not a timeout, it's a deadlock. Timeout is like 68. So you are getting reason code 2, which means it's a deadlock has occurred. Okay. Okay, now the next part. Go to the evmon and copy all the required data in there. Hit enter, and you are done. Okay, so yeah, there your data is there. Now I can go and drop my indexes, reset, and drop the event monitor and do connect reset. Copy that. I can do it from anywhere, I guess. Yeah, probably yes. Okay, this is just, I'm just resetting everything. Okay, so exit, and you can also connect reset and TV to stop. And yeah, we are going to look into the file. So more dl.data. So that's the deadlock data that I'm talking about. So you can see that there are two applications involved in the deadlock scenario, and so this is one, the app ID with 28, the another one is with some other app ID, so I don't know. We'll look into this. So you can see that, see, this is the one, sysibm.systables, So that's one thing that is holding the lock. And I think the other one should be like an internal cache lock, so internal catalog lock, something like that. So any case, I'll upload this file, this observation also, this deadlock data also. For if you want to look into that, you can look into that as well. So you can see that, see, this is the table, sys tables sys IBM. So it's holding the intent exclusive lock. And this is the second application, participant number 2. So that statement history it is showing. This is the participant number 1. Okay, and same internal catalog cache lock. I think that is the problem. So when I looked into that, it was problem with that internal catalog cache lock and the sys tables lock, both the things. So how do I say that? Yeah, so yeah, here you can see that, see here, converting to share, and it's still not granted. So this lock is also an issue, which is the internal catalog cache lock. This is also an issue apart from the sys tables sys IBM schema in the syscat space table space. So apart from, so this lock, so this guy, the other one is waiting for the catalog cache, and this guy is waiting for the sys IBM tables. The other guy is holding the sys IBM tables. It's something like that. Okay, you know the deadlock. Yeah, so these two locks are involved in that. And so yeah, see, this is an internal thing, so we cannot do much anything about it. So that's the tip that I wanted to provide you. And I don't know, I'm not saying this is a defect or this is an issue or something. Maybe that's how it is designed, but just you let me know your inputs, like what is the problem. If you can design it in such a way that it times out, and app 1 times out and the app 2 continues with the second index creation. So what's wrong with that? So it's just a thought. So any case, see you in the next video tutorial. Until then, bye bye.